We need to solve this exponential equation, and then we're going to approximate with a calculator. So it's an exponential because my unknown, my variable, is up in the exponent. And there's different ways to approach this, and what we're going to do is we are going to use this property down here. Exponent, same base property. It says that if you can get your bases to be the same, then your exponents must be the same. So we'll look at this equation that they give us. I notice that the base on the left is 5. Now the right side is not written with a base the way that it is now. So what you need to do is you need to figure out if you can write this with a base of 5. And maybe you can see it, maybe you can't. We'll start with a few bases of 5. We know 5 to the first power is 5. 5 to the second power is 25. Okay, so we have something here. So this is 5 squared. So I could rewrite this as 1 over 5 squared. But that's not quite the base yet because it's down on the other side of the fraction. So the other thing you have to know is that to move something from the top or bottom of a fraction, you have to have a negative exponent. So if I make this exponent negative, 5 to the power of negative 2, that is the same thing as 1 over 5 squared, which is the same thing as 1 over 25. Okay, so I'm going to rewrite this equation. 5 to the 4 minus x equals 5 to the negative 2. Okay, and now we can apply our property. My bases are the same, right? 5 and 5, so I know my exponents are going to be the same. So my new equation is 4 minus x equals negative 2. And this is a linear equation that you should be able to solve. Subtract 4 from both sides. 4 minus 4 cancels out. Turns into a 0. Negative x equals negative 6. And divide both sides by negative 1. And we're going to find out that x equals 6. All right, so this is our exact answer. We solved it. Approximate with a calculator, we don't actually need to do that because there's nothing to approximate. We have the exact answer and it's an integer. It's not anything weird. So at this point, we are done.